Hi everyone, this is Tanishk Yadav, and today we will be doing the topic LCM and HCF from quantitative aptitude. This is going to be the second video, so make sure you subscribe to the channel and make through the entire video. So before getting ahead and start with the question, we will do some theory part, that is basically the definition of both LCM and HCF and what are they commonly called as. So first of all, it is HCF as mentioned in. So here's the thing. For example, if you have a number, let's say 576, this is the number which you are given with, and no, okay, so for first term only, for 576, if you have to take out its factors, what will be the factors? 576 is 24 square, that means the prime factor of, that means 2 cube into 3, that is 24, and it's a square of that, that means it has to be 2 to the power 6 into 3 square. So this will be the answer of 576 prime factorization. Up, you have another number that is, let's say 729. So 729 is 3 into 3 into 3. Okay. So that is 3 cube whole to the power square, and 3 to the power 6. Now, in the two numbers which we are provided, if someone says that tell me a number which divides both the numbers and do not leave remainder, that means it should be divisible and the question should be minimum. That means, for example, if you have 576 chocolates and 729 chocolates of different brands, companies, or whatever it is, of flavors, and you have to divide it in on such a basis that the if you group them up for some certain constant like 25 toffees, and all the 25 toffees at once should be of same flavor. So, what should be the maximum number of toffees in each set? So that your number of sets should be minimum. So in that case, we take the term HCF. HCF is the highest common factor. That is the a number which is a factor of both, but it is the highest possible because if you take one is the HCF of not HCF, common factor of any two numbers. Any real number, one will be the common. I mean, any real number, one will be the common factor for sure. So we have to like one doesn't have that much of a significance. Okay, it has some significance, and that you will see in the questions. But as for now, let's go with HCF only. So HCF is the highest common. In this case, you know that the first one has 6 times 2 and 2 times 3, and second one has 6 times 3. If I have to take a number which is divisible by both, not divisible, which divides both. So that number should be there in the prime factorization of both of them, which makes it clear that 2 or any power of 2, like 2, 4, 8, 16, none of them will divide both of them because 729 has no 2 in its expansion, which makes it clear that it has to be 3 to the power something. But what something? 2, 3, 4, 5, 6, because that's all we have. If you see clearly, 6 can't be there because the 576 term has only two threes. Or same with 5 and 4. They can't have it because the first term, that is 576, doesn't have them. We will go with 3 square because 3 square is here as well. That is 3 square into 3 to the power 4, and here as well. 3 square is common at both places. So that's it. HCF of both numbers, that is, I will represent it in this way. It's a general convention how to do it, is equal to mm, uh, 3 square. That is 9. Now for the second part, that is the LCM, the least common multiple. Now this time it is given that like for example, I tell you that every 3 minutes I slap this. Okay, that may be a bit violent. Every 3 minutes I use this hand to like hit on the bench, and every fifth minute I use this hand on the bench. At 9:45, I did it with both the hands together. And after that, every third minute this, every fifth minute this. So after how long will I hit them again? So in that case, you have to see like 9:45 is the thing. 9:45 I have hit with both. Okay. Now for the right hand, it will be 9:48, 9:51, 9:54, and 9:57 and 10 o'clock. Okay. And as for the left one, it will be 9:50. That means somewhere in between here. And 9:55, that is somewhere here. And again 10 o'clock. How we got this? HCF of LCM. How about LCM? 3 and 5 are prime numbers, so their factors will be 3 and 5 only. Those two terms are co-prime, twin prime as well. So in co-prime, in cases of co-prime number, the HCF is simply not HCF. LCM is simply the product of those numbers, which is very clear. I'll tell you again. 3 into 5, that is 15 minutes. Every third minute, every fifth minute, 15 minutes, and after 15 minutes, that is 9:45, 15 minutes, that is 10 minutes, and you have the answer. That after every 15 minutes, I will hit the bench with both the hands. That is HCF. In case we have a bigger number, for example, again 576 and 729. I'll erase. Okay, not erase, but I like to drag it down a bit. Hmm. Let's solve it with the red pen. 576. Now you have to find a number which is divisible by both. That is, it should be greater than both or equal to at most, but it shouldn't be lower than that because then it won't be divisible. It should be a number which has the prime factors of 576 as well as 729. For such a number, it should have all the factors, or at least all the factors of 576, and at least all the factors of the other numbers as well. I'm taking just of two numbers, so uh, simple way to do it is write the prime factors and then do it like this. LCM of 576 and 729 is equal to write all the prime numbers 2, 3, 5, 7, whatever is there in the expansion. For example, right now we have only 2 and 3. Look at all the numbers. Best is to use the method like write it in this form only 2 to the power 6 rather than writing 2 into 2 into 2. It's not easy to do that. It takes time. Okay. So 2 to the power 6. The maximum power of 2 in both the expansion is 6. So I'll simply write 6, 2 to the power 6, multiplied by 3 to the power. Maximum power of 3 is at in 729. That is 3 to the power 6. This will be the LCM. That is 6 to the power 6. If someone wants to know why 6 to the power 6, goes into YouTube. Or write in the comment section, I will make a short video. 6 to the power 6, somewhere 216 cube. 216 square. I don't care. What is the answer? 435, something. After that, definitions are done. Some common terms, that is coprime. Although I told it in the previous video as well, coprime are the numbers which might be composite number individually. For example, 9 and 8. They are both composite numbers. This is 3 into 3, this is 2 cube. But they are coprime numbers because they comparing to each other, they don't have any common factor. That is coprime. And as for twin prime, for example, 2, 3, 3, 5, these are the consecutive prime numbers. I can't say 3 and 7 is a prime, twin prime set. So that's it. These are some basic things you should remember. Now, let's get ahead with the questions. For first question, there is a number greater than 1 which when divided by 4, 5, 6, leave the remainder of 3 in each case. Find the largest number smaller than 1000 which satisfy the given condition. First of all, we will look at the first sentence because second sentence has to be solved later. It is given that if you divide a number, for example, x is the number. If you divide it by 6, what is it, 4 or 5 or 6, remainder will be 3. So remain for the remainder as 3, ignore the part. If the remainder is same in any question that dividing any set, so any amount of numbers that these many numbers are there, ignore the question that there was some remainder statement. Just remember that, okay, 4, 5, 6, you divided it with 4, 5, 6. Find their LCM first of all. LCM of 4, 5, and 6. That means, let's do the method I told you. 2 square, 5, and 2 into 3. What is the maximum? Now we will write 2, 3, and 5. What is the maximum power of 2? That is 2 square, multiply by 3, once only, 5, once only. So this is 60. LCM is 60. Now, the question you have to look first of all the last statement answer. If it wasn't asked that it should be maximum number smaller than 1000. If it was it was written that the smallest number, we would have simply added 3 to this. Because if you divide 60 by 4 or 5 or 6, you will get the quotient as some number and remainder as 0. Now, beyond that point, if you divide it with any number, like if it is 63, so 60 out of 63, 60 is divisible, and 3 will be the remainder always, be it divided by 4 or 5 or 6. So that's how we proceed in this question. But here the situation is different. It should be maximum number smaller than 1000. In this case, we divide 1000 by 60. 1000 by 60, it is somewhere 16 is the smallest number. 16.66 is the method. But for integer, we will say 16. 16, that means, I guess, 960. Yeah. So 960 is the number smallest, I mean, smaller than 1000, which is divisible by all three. It's not the answer, it is divisible by all three. Now we will add 3 to it. After adding 3, the answer is 963. This is the maximum number which, when divided by 4, 5, or 6, it leaves the remainder 5. 963. And because the simple reason, because 960 plus 60, right, that means the next number when this occurrence will be happening, it will be greater than 1000. So this is the maximum situation. 963 is the answer. Option D. Okay. Answer. The second question. I'm not sure you guys were able to see this or not, but I'll share the file in the description as well. My bad, I didn't realize I've kept my video at the top this time. Hmm. Second question, find the smallest number that leaves a remainder of 4 on division by 5 and 5 on the division by 6, 6 on the division by 7 and 7 on the division by 8 and 8 on the division by 9. Is this question, like, I'm not sure, even if you know the answer, in most of the cases during examination, this is a question you can't solve. Mostly can't solve until you are preparing from a lot of time or you have recently done this question, you will be able to. But most of this, like I have done it many times, I forget it every time. I have to spend hours to apply the logic how to proceed with it. But for the exam purpose, when you have a time constraint, you get less than 2 minutes for each question, less than 2 minutes. You can't go with those methods. Simple method. First of all, see that it has been divided by 5, and then it leaves a remainder of 4. A number which is, that means, if for example it was the number was 5 only, when divided by 5, it leaves the remainder 4. That means the original number must be 9, and when you divided by 5, it left the remainder 4. Or in case of 10, it will be 14. So since it is divided by 5 and leave remainder 4, uh, divisor and remainder 4, that means number has to end with either 4 or 9. All the options has. In case it doesn't have, then at least eliminate some of the options. Uh, as you can see, option A and option B, the option B is just the double of it. Most chances are option B won't be the answer because it is not the smallest number, and if it is able to do something, then option A will definitely do it, and it is not the smallest, so option A can be the answer. Option B can't. Now, 5 on division by 6. Best method, a number when divided by, like, better to solve all the options. That is the best method. Certainly the best method. In especially this kind of question, I won't say for any other question. Some questions it is better to go with the options itself. So in that case, just I guess option A should be the answer. Option A, adding the digits. It is 7, 8, 8, and okay. So this is not divisible by 6 and leaves remainder 5. Yeah, yeah, definitely. Mm-mm. Hmm. So option A and B are the only options, I guess, which does that. Option A, yeah, option A is the answer for all the conditions. Better to do it this way because solving this question itself takes a lot of time. And I know most of you don't even watch the video completely, so not a point. If you want detailed, I will make another video for just this question. Like 5-10 minutes video it will be there. I'll explain this question in detail. If you want, just put it in the comment section. Even one comment will be there. I'll do it. Find the greatest number of 4 digit and the least number of 5 digit number that has their HCF as 147. So 147 is actually 49 into 3. That means 3 into 7 squared. This is the time factor addition. In this question, I would suggest go with the options rather than solving the actual question. I'm not saying solve the question totally. Look at the options. 9996. Is it divisible by 3? Yep, it is divisible. 10143. 437, 8, and 9. It is divisible. 99936. It is divisible by 3. Okay. All are divisible by 3 except for the last one. No. All are divisible by 3. Not a problem. Now see if they are all divisible by 7. We will eliminate half of the options like this. 9996. Okay. So 9996. Better to go with shortcuts, but if you don't want that, I'm solving it for you. 29. So 4, 28, 1, again a 9, then 14, 5, and 6. It is divisible. That means triple nine three six nine six triple nine six is divisible. So triple nine, not triple nine, double nine, 36 can't be divisible. That because for being the multiple of 70, there is no multiple of 70 which end 7 which ends with a 6 other than the eighth multiple or 18th or any of those kind of multiple. In first 10, only 8 is there. That means after every 10, 6 will be the ending digit, ones digit. So it has to be 99996 minus 70 only, which can satisfy this situation. So what we will do is that means I mean 9936 can't be the 9936 can't be this option. The smallest number, the 4-digit number, it can't be there because it has to be 9926 because it will be 70 less. Option B and D are eliminated. Don't go with them. Now we just have to look for the second part. That means the 5-digit number, smallest 5-digit number. For smallest 5-digit number, they are both divisible by 3. Do not check. Now check again for 7 only with 10143. Let's pick this. 7. I'm not writing question. 7, 3, 1, 28, 3, 4, 6, 6, 28, and this is 6, 63, 9. Okay. Option A is the answer. I'm not checking the second C option because obviously it won't be there. Or you can even, if you want to check, check for 1008. Ignore the 0. It can't be, it's not easy. Option C is the answer. 1 double nine. 996 and 10080. Question 4. How many pairs of positive integers x comma y exist such that HCF of x comma y is 35? Sum of x comma. Okay, great. This is the easiest question you can find. HCF is 35. Okay. Uh, the two numbers can be, for example, let's take any arbitrary number A or B. Okay. So the two numbers which we need, they will be mostly A. 35, not mostly, they will definitely be 35A and 35B, where A and B are co-prime numbers. Because if they have even one common factor, that would have been the part of HCF. Okay. So A and B will be co-prime numbers. Sometimes you might need it that they have to be co-prime. They can't have any common factor. Otherwise, it will be a part of HCF. But let's ignore it for right now. Not ignore, but it won't be of any significance in this question. Now, second situation which we are given, 35A plus 35B, we have it equal to 1085. Wait, it says that HCF, okay, okay, yes, yeah. A plus B is equal to 1085 by 35. And what's the answer for that? Okay, I mean, it's clear though. 31 is the answer. Just thinking to do it. 31 is the answer. A plus B is equal to 31. Now, here you have to use that thing. In this question, it won't matter. But you are given A plus B. You have formed a relationship A plus B is equal to 31. You have to find two prime numbers, two co-prime numbers, not prime numbers, two co-prime numbers, which add up to 31. Sorry, the rain is coming right now, so there would be some noise. Try to ignore it. A plus B is equal to 31. Now, we have to form the pairs. How many pairs are possible? So, it can be 1, comma 30, they are co-prime. 2, comma 29, co-prime. 3, comma 28, yes, they are co-prime. 4, comma 27, definitely co-prime. 5, comma, what is this? 26, co-prime. 6, comma 20, wait, comma 20, 5, co-prime. 7, comma 24, co-prime. And 8, comma 23, co-prime. 9, comma 22, co-prime. Now this makes sure that what is the maximum number? Okay, 30 is the maximum. Option C is not the answer. But if you see now, all will be there. 12, 13, 14, 215. There was then 16 and other things. All these are co-prime couples. I guess this is 15, 19, 18. What the hell did I do? Ah, it has to be 20. And 21. There are 15 pairs which satisfy the given condition. Option D. Just in case the sum like A plus B would have come 32. Then other than 1 and 31, if you go for 2 and 32, 2 and 30, it will be eliminated because they are not co-prime. Now, and for next 3, comma 29, it will count. In that question you would need, but since it was 31, all the 15 would be co-prime. In that situation, like keep that in mind. For the fifth question now, oh, that. Find the least number that should be added to 2014 says that the least number that should be added 2014. Okay. Same, just like we did in, I guess, first question. Yeah, just as we did in first question. First question, we took a number smaller. This time we will take a number higher because this time we have to add the number. So it has to be 3, 4, 5, and 6. Again, 3 is 3, 4 is 2 square, 5 is 5, 6 is 2 comma 3. Ignore the 2 comma 3 because 2 and 3 are already there. So maximum power is 2 square into 3 into 5. Again 60. LCM is 60. That means every 60th number will satisfy the condition that the number is divisible by 3, 4, 5, 6 without leaving any remainder. Now, a number greater than 2014. Divide it to 2014 by 60. In exam, you don't have calculators. Well, you do have, but just in case in any exam, a calculator is not there. If you have the calculator, then simply go like this because most of the exams are online only right now, so it won't be an issue. 2014, sorry, not bad. 2014 divided by 60. That means 33 is clear divisible and next multiple 34 we have to look. So 60 into 34. 60 into 34. 2040 is the next number. And this is 2014. We have to add 26. 26 will be the answer. In case you don't have, solve it. When you divide, there will be a remainder. Remainder will be 34. Okay. Because 1980 is the number which is divisible by 60. And 1980, after 1980, it will be 2060. But since you already have 2040, you need 20, you will get a remainder of how much? 34. 34 will be your remainder. So subtract 34 from 60. You need next 60 now. The next 60 you need subtract it. You will get 26. And the answer will be C. Option C. Sixth question. Sum of two numbers x comma y is equal to 1050. What will be the maximum value of HCF between x and y? This is a question. I don't know like how and why should you do it because sum of two numbers is 100, 1050 and you have to find the maximum HCF. For example, if you take 1049 and 1 because you or even if you want 0 and 1050 then there is no HCF. So HCF can never be option D. 1050 can't be HCF because then the sum will exceed 1050. 1050 and 1 have the even they don't have. Ignore it. So that's not possible. Option D eliminated. Option A doesn't make sense because if one of the number is 700, the other number will at least be 700 to be the HCF. And if it is 700, then it will exceed the condition of sum as 1050. Doesn't make sense. Option A eliminated. Option B, it is possible because 700 and 350, that is the second multiple and the first multiple, they have the HCF as 350 and sum also 1050. It is possible, but it's not the answer. Usually, we have option C, 525 and 525. They are same numbers. Their HCF will also be 525 and sum will also be 1050 and is a maximum number. That's the answer. And actually, this is how we do the question. If two equal numbers will give the maximum answer. I don't think I have to write this. This is option C. Okay. Let me write it for the answer. Yeah, this is sixth question. Option C, 525. I'm not solving it here, so I need somewhere to go. Question 7. Here we have sum of two non-co-prime numbers added to their HCF give us 91. See, 91 is 7 into 13. So sum of two non-co-prime numbers. Okay, they are not co-prime. Yeah, great. How many such pairs are possible? We will simply first of all go with writing what we are given with. That is, let HCF, I am writing HCF as H. And just like I did previously, let's take the co-prime parts as HA and HB. HA I am taking as, okay, there is nothing, no A or B. HA plus HB is equal to, okay, it's not equal to, plus H is equal to 91. Now H I am taking as common one, this is 91. If you are aware, then H can either be 1 or 7 or 13 or 91 itself. But 91 is not possible because 91 into 1 can only give 91. And this bracket, it won't be 1 because A, B, and 1 are all three natural numbers. Can't even be a whole number. So 91 can't be possible. Only three options are there. Now, for each situation, we will make the cases. If it is 1, then A plus B plus 1 is equal to 91. A plus B is equal to 90. We have to break it down into two co-prime numbers. But wait a minute. In this situation, actually one more thing is given that they are non-co-prime numbers. If one is the HCF now, they are co-prime numbers. So even one will be, my bad. I ignored this. This is how dangerous these questions are. Now for 7, that means 7 into something. Something is 13 only because 7 into 13 should be equal to 91. H is equal to 17. So A plus B plus 1 is equal to 91. For A plus B plus 1 equal to 91, that means A plus B is equal to 12. A plus B equal to 12. Now A plus B, that means A two co-prime number with some 12. 111, actually it can happen, yeah. They are not co-prime because with 1 we don't find co-prime. I did that mistake earlier. I said 1, but we don't say it co-prime. Okay, then 2 comma 10, not possible. See, 3 comma, no, okay, 3 comma 9, not possible. It's 4 comma 8, not possible. 5 comma 7, it will be counted. And 6 comma 6, yep, it will be counted. It is possible that the numbers are same. Is it? No, it's not. If you have two numbers, then the HCF will be the number itself. If you have 6 comma 6, then 6 should be, I mean, 42. That means 42, 42. Then the LCM should also be 42. It's not possible. Only two cases when 7 is there. Now for 13, 13 into 7, that means A plus B equal to 6 now. For A plus B equal to 6, co-prime numbers 1 comma 5 and 1 comma 5 and 2 comma 4, no. 3 comma 3, again no, due to the same reason. So only three cases. Now, when A and B are is either 1 or 11, 5 or 7, or 1 or 5. These are the only situations. So how many pairs? If you want the pairs, I'm listing them down. First is when it is 7 into 11, that means 7 and 77, 77 because if you add 84 plus their LCM is 7, then 91. Okay. The second pair is 35 and 49 plus 7 because their LCM is 7, again 91. And the third pair is 13 comma 65 plus 13, again due to the same reason. These are the three pairs. Three pairs. Eighth question. There are two numbers such that A is greater than B. HCF of A, okay. LCM of. Do you remember the property which you did? I didn't revise it right now, but there used to be a property that LCM of a number into HCF of a number is equal to product of two numbers. If you want proof, I will make a short, YouTube short on this thing. We are given LCM, that is L into H is equal to A into B. Okay, we already know it. We have just substituted it. Now it is given that, see, it's a simple fact when, for example, again, uh, actually we are given that HCF of A and B is H. But how do we know that what is the HCF of A minus B and B? So it's a logic. For example, for an instance, assume that A is equal to H of, like, H is already there, no? Yeah. So Hx, B is equal to Hy. And now you need to find the LCM of these numbers, of the numbers A minus B and B itself. So if you write A minus B, that is H comma X minus Y. So you took H common from here as well. That means H will be the common factor of that situation as well. This is how we find it. So H will be the HCF in the second case as well, because both have already have H with them. So even in this question, we can again rewrite it as L is all L new L, that is LCM, which we have to find, multiplied by H. We know HCF is same, is equal to A minus B into B. And LCM is equal to A minus B into B upon H. Option B, done. As simple as that. These questions have come in the exams. You do not have to use. Ninth question. Six different sweets of varieties are okay. 32, 2, and 6 were ordered for a particular occasion. They need to be packed in such a way that each box has same variety of sweet, and number of sweets in each box is also same. Simply nothing but HCF. Because you have to divide it into equal pieces. There should be no leftover. You need to find the HCF only. So HCF of 32, 216, 136, 88, 184, 120. Let's do, we have a lot of time. So if you want, you can skip okay, 1 minute. 32 is equal to 2 to the power 5. 216 is equal to 2 cube into 3 cube. 136 is equal to this is 2 cube into 17. Okay. And next is 88. This is 2 square, I guess. No, 2 cube into 8. 2 cube 11. And 184 is equal to 2 cube into 23. 120 is equal to 2 square into 3 is 12. So 2 cube into 3 into 5 will be 120. I did it like 2 square into 3 into 2 into 5. That's how I did. For HCF, what is the least power of 2? Okay, here also do the same thing. Write all the configurations given. 2, 3, and 5 is there. 11 is there. And 17 and 23. 11, 17, 23. In this question, in this, like in HCF, you have to do the reverse of that thing. In HCF, you have to do the reverse of that thing. That is minimum power this time. For minimum power of 2, we have 3. This is the minimum. For 3, 0. For 5, 0. For 11, 0. Obviously, option 1 is visible that all of these will be 0. 2 to the power 3 is their HCF. Now, 8 is the HCF. That means each packet will have 8 of each sweet, like multiple of 8 kind of thing. You will take the total sweets. You will take the total sweets, add up them, and divide them by 8, which will be, ignoring the calculation, it will be 97. Uh, that means 720, okay, 693 something will be the sum of all the sweets provided to us. Okay, so 97 boxes. Option B. 10th question. LCM of two numbers P and Q where P is greater than Q is 935. What is the maximum always possible sum of the digits of Q? First of all, 935 is equal to, this is 10th question, 5 into 11 into 17. If you wanna check it. This is the factorization. Most of these questions, if they have great numbers, that means they will be part of 2, 3, or at most 4, at most, uh, big prime numbers. So 5, 11, and 17 is the expansion. Now maximum possible sum. In this question, you have to take cases. So for the case 1, if HCF is equal to 1, then the possibility of P and Q are P is equal to, let's say, 55, that is 5 into 11, and Q is equal to 17. Other possibility, P, three possibilities, obviously three are there. If you have studied combinations, 3C2 is equal to 3. So P is equal to 11 into 17, that is 187, and 5 into 17, that is 85. And for the corresponding parts, Q is equal to 5, and Q is equal to 11. This is sum 8. some 5, some 2. Now, if h is equal to 5, p is equal to 5 into 11 and 5 into 17, two s's are only there. So 5 into 11, that means p is equal to 5 into 11, 55, and q is equal to 5 into 17, that is 85. Same 5 into 17, that means 85. Wait, no, only one case. H is equal to 11. Yeah, the cases will be 11 into 5 and 11 into 17. 5, p is equal to 11 and 11 into 17. Q is equal to 187. Sum is 13. Sum is 2. Till now, this is the greatest, and I bet this will be the greatest. And H is equal to 17. One case, P is equal to 5 into 11. If you have realized, I'm actually taken all the cases twice, but better understanding. Because we can interchange the value as well if you want. So for 187, we can see Q is equal to, this will be 17 into 5, sorry, 17 into 11, 17 into 5. This will be 85. If you are able to see, there is problem with some of the equations which I have written, but let's skip on to that for a while. Now let's see the combination. There can be 55 can also be the HCF. So 55, for example, so it has to be 55 into 17 and 55 into 1. 12 into 17, what is the answer? Obviously the number itself, that is 935. Okay, 12 into 7, 55 into 1. Q is equal to 1. 13, 1. Now H equal to 55 into 17. Now 187, if that's the case, then P is equal to, okay, if I want to save the time, look at the question. P should be greater than Q. That's the fundamental thing we have to assume. So we won't write now. I don't want to waste time. So for H equal to 1, uh, this one is correct. This one is also correct. This one is also correct. Great. 13, this is not correct. Other way around, was it possible? 5 into 13. Yeah. Okay, so you can have it, but you have to reverse that. But this one is not possible. For H equal to 11, that means it could have been 85 and 55. I wrote this wrong. 55 this is. 55 is this part. Okay. So this has to be 10. Now for 11, it has to be 187. This should be 187. And this has to be 155. Again 10. For 17, it is correct. For 55, 935 and 1. Great. And for 187 into 187, it is 5 into 17. P should be the 11th multiple. 187, 11th multiple, that is 935. And Q must be 187 itself. And now it's actually the waste to now choose 5 into 17. Doesn't make sense. 5 into 17 will be 85 again. Okay, you already chose 85. Yeah. So this is the maximum sum. That is 16. 16 has to be the answer. Still not clear? Ask in the comment section. I'll explain it beautifully there and will pin that comment. If you're clear, then move on to the next question. HCF of 2 comma 3. I don't know why was this question given. I searched it from a website. 2 by 3 and 4 by 6. Aren't they the same thing? Ignore the 4 by 6 then. 2 by 3 and 8 by 27. You have to find the HCF of them. Sometimes people think that write the expansion of numerator, expansion of denominator, and you will be able to find it. But it's better if you do it this way. Take the LCM of the denominator. That means 2 into 3. In this question, it's easy because it is 2 into 3 cube. This is 2 cube upon 3 cube. This is totally visible. But in case if it's not, it's a complex part, make the denominators same. Multiply is by 3 square. This is by 3 square. So it will be 3 cube. And common part is 2 by 9, 2 by 27 is your HCF. Option A. Four logs of woods of length of 5.25, 1 and 30. Okay. Read the question carefully. Try to attempt it and I'll start. Now, first of all, convert them into fractions, improper fractions. 21 by 4, this is 28 by 15. And this is 7 by 2. This is 49 by 10. Same thing we have to do again. You have to find the HCF again because you have to cut them down. These are the maximum lengths and you have to find the actually keywords help a lot. It is written as lengthy as possible and the minimum required. Minimum number required or as lengthy as required. That means you have to find the HCF. And it is given that this is the total thing you have. So that means you will only cut them down. You can't multiply them. That is HCF. Take HCF simply. So HCF again, expansion of this. Okay, first of all, denominator 2 square, 3 into 5, 2, and 2 into 5. HCF is equal to HCF of denominators is equal to, keep in mind, denominators 2 square into 3 into 5. Again, 60. Take everyone 60. That means 21 already has. I'm doing it once. You have to make it 60. That means multiply by 15. Multiply by 15. Remove these part. 21 by into 15, comma. For 15 you multiply it by 4. 28 into 4, comma. 7. You have to make it 60. Okay. 210 or write it 7 into 30 only. And this is 49 into 6. Denominator for HCF, since all denominator are same, their HCF will all be 60 only. We made it same. But to make the numerator also, you have to take this part. You can write it as 2 by 2. This is 3 into 3 square into 5 into 7. This is 2 to the power 4 into 7. This is 2 into 3 into 5 into 7. And this is 2 into 3 into 7 square. What is the common factor in each one of them? Uh, Only 7. Because here 2 is not there, in second one 3 is not there, 5 is not there, so only 7 is there. 7 by 60 is your HCF. Now, this is the HCF, but we have to find how many carpenters. Each carpenter gets, each piece is received by two carpenters. First of all, we need to find number of pieces. So HCF, that means you can cut it into lengths of 7 by 60 meters. Now, total length, either take the sum or better, I would suggest going with the sum because you have to add fractions. It's not easy. If you can, then go for it. But session 21 by 4, you have to make you have to make this HCF. H into something should be 21 by 4. H into something. So for that something part, 7 by 60, if you have to make denominator as 15. Sorry, 4. You have to multiply it by 15 first of all. So that 15 gets cancelled. You can cut them by 4. And you have to make numerator 21 as well. So multiply by 3 extra. You got it? So this thing is, you need 45 pieces. 45 pieces of that length will make the desired length, that 5 and 1 by 4, 5 and a quarter. You need 45 pieces of wood A, that means 45 and 28 by 15, you have to make it into 60. How much? Wait, this has to be formed. So 7 by 60 multiply by what is equal to 28 by 15. Denominator should become 15, so that means multiply by 4 first of all. Then numerator should become converted into 28. Again a 4. This is 16. 16 pieces of this. Now 7 by 60 into what should give 7 by 2? 30 first of all to make it 2. And numerator is 7 only, so no worries. It should be 30. And last one, 7 by 60 into what is equal to 49 by 10. 6 into 7. This is 42. Taking sum, this is 133. Now 133 pieces given to, like each piece is given to two carpenters. So you have 266 carpenters working on the project. That is option C. In a large school auditorium, the students are made to sit and watch a program. Okay. Okay. So teachers make a row of you also read. Mute me if you want. Okay. So in such a question, if you can notice, the remainder in each case is 4. Don't you think it is actually similar to the questions where it is given that leaving remainder 4 in each case? It is very much similar to that part. So we are going to follow a similar approach. This time also we'll find the LCM, but instead of adding it later, we will subtract it later so that the LCM will be divisible by all. But if you reduce 4 from each of from the number, then no matter how many rows you make, it will always be short of 4 because the original number is divisible. Now reduce 4 and it will all be solved. 4 is the remainder in each case. If it was given to you directly, you would have done it. But since this is given in form of a word problem, the language part, it's not that easy to do. Not easy. Not easy to figure it out. So 16, 24, okay, 16, 24, 25, and 30. 16 is 2 to the power 4. This is a 2 cube into 3. This is 5 square. And this is 2 into 3 into 5. That means, yeah, 6 into 5. No? Now we will write 2, 3, 5. 2 highest power 4. 3 highest power 1. 5 highest power 2. So this is equal to how much? 3 power 4. 2 square into 5 square is equal to 100. Okay. Now 2 square into 3. That is 12. 1200. 1200 are the students. Ideally, if it were 1200, then in all these combinations, that means 16 students each and 24 students each, and all these conditions will be met. But since you reduce 4 from them, that is 1196, all the situation will have 4 as the vacancy will be there. So 1196 is the answer. That is option B. If you have any doubts, put it in the comments. Ram wants to utilize his unused. Okay, I'll stay silent. You read it. Again, a question of HCF only, that there are different kinds of plants, and Ram wants to have minimum number of rows, and maximum trees in one row. But given the condition, he can't mix them because if you can mix that, you can have 5 trees in front of mango, then 4 trees of apple, though they can't grow in the same region. But if you try that, if that's the condition, then square will be the most efficient way. Or if they say just the row should be minimum, keep on single row. But in these questions, it is given that only one type of plant should be there in a row. So for that case, we have to look at a situation that 88, 732, and 220, they should be cut down into minimum number of pieces such that, okay, that's the only thing you have to do. Just we have to cut down into minimum number of pieces such that the number of trees in each piece is equal for all the plants. Okay. HCF only. 88 is 2 cube into 11. 132 is 2 square into 3 into 11. And 220 is equal to, this is 110 into 2, na? 2 square into 5 into 11 into, now, what is the HCF? Only 2 and 11. I mean, 2 square and 11 is equal to HCF is equal to 2 square and 44 is the HCF. So, two rows of, uh, two, huh, two rows of guava and three rows of papaya and how many? Five rows of what is sugarcane. Sugarcane. I don't have space. Don't think I don't know this spelling. This is 10. 10 rows will be there. Option A. 15th question. Again, if you are all able to figure out, we have come this far. Again, HCF you have to find, nothing else. You have a code, you have to keep minimum number, you have to keep minimum number of tiles. You'll find the maximum like, length should be divisible by that thing, and square tiles are there, na? So in such a way. 1517. 1517 is 1517. Its factors are, I guess, 37 into 41, maybe. I think so. Check it out. Let me check. And 902, 902 is equal to 2 into 11 into 41. LCM, HCF. HCF is equal to 41. Option D. Next. In this question, actually, I was trying to solve it, but I think we have to assume one thing, which no one said that we have to assume one thing, that we are given that 200 we can do maximum per session. And like we have to assume that after the change, after changing the condition, if we have certain number, like, okay, let's solve it. For example, we were using S number of six. This is the solution I even referred to. S number of six we were using, and S is given less than 200. This is a constraint we are provided in case we can multiply it as well. Na? We take it under 1,000 or something. So number of match box, sorry, number of matches per box. Initially we had S upon number of boxes. Wait, I'll keep the S small. S B minus 25 you have removed from each box. You are able to make 3 extra. That means B plus 3. We have to assume that we are still using the same number of sticks, because this was a bit conspicuous because what if we were using initially 180, then after making the changes we are using 175. So this came in CAT 1991. It's been long, but I don't know why they gave it. But they're equating it right now. So solving this question, we let's assume it only. S minus 25B plus 3S by B minus 75 is equal to S. S is cancelled. Now multiplying both sides by negative B. Okay. This is 25B plus 3S. Sorry, not plus, minus. And then plus, okay, this is B actually. So it will become B square, 3S and minus 7 plus 75 B is equal to 0. Now here's the thing, when you like the number should be like 6 should be an integer. In that case, the discriminant should be a whole square. If you want to try it, then at least try it once, solving it. Why? Like, what is the why is the discriminant be a whole number? If you want to try it, then you can try it that why should it be a whole square? Because it actually you can't get the output. That means after solving the quadratic equation, you can't get the answer as a whole number if you don't have a whole square. Answer will have like fraction or irrational number, irrational anything can come. So it has to be a whole square. So it will be 25b square minus 3s standard form by b minus 3s. Now d is equal to 75 square plus 300s, simple b square minus 4ac. Now, which is very clear that 75 square, if we take it common, it will be 1 plus 375 common, that means 4 by 75 s. Now, 75 is already a square. The only square we need to make is the this part. And for this part, we need to give s such a value that it becomes a whole number, which adds up with 1 to make it 1. Uh, okay, we won't make it 1. We will make it 3 next because we have to keep it square. 1, 4, 9. To make it 4, I mean this entire term to make it 4, we need to make this 3. To make it 3, we have to first multiply it by 75 to cancel out the denominator. And then, but 4 is already there in the numerator. We can't deal with that as well. So we will go next to 9, which means this part should be 8. First of all, 75 and then 4 into 2. And it is less than 200 as well. So 150 is the number of matchsticks. This is your answer. Option, uh, sorry, is option 150. Option D. Now next is 17th question. Here we have a new flag is to be designed with 6 vertical stripes using some or all the colors. If you have done permutation and combination, the where you used to form like given you have cards, where you used to do that. In this question, the thing is you have a flag where you have 6 vertical stripes, but there's a condition. You have to use at least like you can use all the colors or at least one you have to use. Obviously, you can't use one, you have to use at least two. But any two adjacent stripes, they shouldn't be of same color. Now, how to do these questions? You remember you used to do it like first position has 5 options, second position has 3 options. These things. In such a situation, what is the for the first position? How many options do you have? All the options, 4. Next position, how many options you have? You will say it is complex because on the right also you have something, left also you have something. Forget the right part. Just go from left to right and see. On left you used a color, on right you have a space. So you will have only 3 options because one is used on your left. You can't use that one. Other than that, all you can use. Now for the third one, this one, same thing. Because you don't care about what you entered here. You can use it again. Again, you have 3 options, and repeatedly you have the same options. Answer will be this is 12 and this is 81. Option A. It's not necessary it comes in the same format as 12 into 81. Maybe it's directly product or PNC form also can be there. 3p4 into this thing, which gives the same answer. Because they never say the equation will be according to logic. If it asks, then we have the logic. 18th question. In a class, every third question is related to English and every fifth. That means the same. This is the reason I gave that example. Every third question is of English, every fifth question is of maths. What is the maximum number of questions which the test can have? What was the answer? 15 is the LCM. 15 after every 15. it will repeat. So if third question is English, for English we have, and for math we have, sorry, not math, it's history. For English we have third question, sixth question, ninth question, 12th question, and 15th question. And for history, if we see, we will have fifth question, 10th question, and 15th question, which contradicts the fact that it belongs to only one of them. It can't belong to both of them. So the maximum questions, that means it should stop at 14 itself. It shouldn't go to 15. It can't go beyond 15. It can't be 15. So 14 is the answer. Option B. So that's all for today. The next chapter will be uploading soon. I guess next by next week for sure. It will be heights and distances, and it will be covered by Sanjana. And that's all for now. I would, if you want some help using this PDF, first of all, you can download the PDF from the description. Second thing, if you, I guess, access here, if you access, click on the PDF here. Okay, I didn't sign in on this. Uh, if you click here, then you will reach to the channel page. You can see the videos here. Okay, and if you want to see the video itself, right now I have added the link of the previous video just to show. If you click on this, you will be shown. Okay, I didn't add. I added the channel link only. The moment I upload it, I will provide the video link of this chapter when you click on this image. And if you want to connect with us, you can use LinkedIn to connect with me, YouTube for our channel, Instagram, Telegram, anywhere you want to connect, we will be there. Quora, we have a space. Gmail, if you have any offers or any queries, like very personal queries, if you want, you can ask there. And Discord also, we have a server for Science Valley. If you want to join there. And that's all. Yeah, if you want to buy the books, like the books I personally referred while preparing. Okay, I didn't go for MBA or something, but I studied it a lot. So it was Fast Track by Arihant. It is a good book. I would say it has a lot of questions. If you are starting early, it's the best book you can go for. You might find some mistakes, very rarely, but if you have any queries, you can simply reach out to us in the Telegram or Discord. We will be there to help you. You can buy the books from here or anywhere. Mostly Amazon. These books were cheaper as compared to Flipkart, so I added Amazon link. That's all. Any queries, anything, just put in the comment section. Join the group. Do it, whatever you want. And if you need any help, if you need any sample questions, just reach us out. And that's all. Thank you for joining us today. See ya.